good evening, good morning, everyone, wherever you're joining from. You are welcome to this workshop organized by the data engineering community. My name is Najeeb Sulaiman. So if you're meeting me for the first time, I'm also a data engineer. I currently work with Jaguar Land Rover UK. I'm the founder of data engineering community. So data engineering community, for those that are joining us for the first time and will not be aware of enough information about data engineering community. So it's a platform for data engineers across all levels, for beginners, for aspiring data engineers, for experienced data engineers across all levels. So where we come together to learn together and grow together. So we've been operating since last year, January, so 2 years running now. And this webinar series is something that kickstarted January 2024. So it's a platform we are trying to put together to serve as an avenue for us to come together, as I've said, to learn together by leveraging on everyone's experience, both people in the community and members outside of the community. So we started January having a couple of webinars, couple of workshops in January. So this is like the fourth one. This is the fourth one. And today we'll be discussing about a very important topic, something I believe is very interesting and very important in data engineering and software engineering practice generally. So helping us on that is Idowu Lekora. So who is a seasoned data engineer, so he's also well experienced as well. And I'm very confident we are going to gain a lot from his wealth of experience as well, taking us on this journey of leveraging Docker and Docker Compose to build up pipelines. Yeah, so without further ado, I will hand over to Idowu to walk us through, introduce himself and let us know what we have today. But before we start, so just to give us a kind of prepare our mind. So this is scheduled to be a 2 hours workshop, but we'll try as much as possible to spend less than that. So if possible, we can spend 1 hour on the main workshop, then 30 minutes for question and answers and interactions. So as much as you want to learn from the speaker, so we also want to get insights from members of the call. So we believe we can learn from anybody on this call. So if you have any questions, please take notes. Once we are done with the main presentation, we'll get questions and interactions from every members on the call, so we can learn together, as we've said. Yeah, so thank you everyone for joining. We appreciate joining us on this call. So stay tuned and Ido, over to you. Thank you also. Thank you, Ido. So I won't forget to to appreciate you, for your efforts for trying to put this together and helping us understand, learn from your wealth of experience as well. Thank you so much, Ido.
Thank you. Thank you, Najeeb, for having me. Can everyone hear me? Hope my voice is clear.
We can hear you.
Okay, so I think before I start, we need to download or clone the GitHub repo where the files for this session or webinar will be. I think it was shared earlier on the group. So if possible, just clone it so that when we go into the hands-on session, it will be very fast. And for those that might have like network issues or some things, it will be good if you download it on time so that you won't have issues when we get to the hands-on session. Okay, so my name is Do, and I'm a data engineer. Although currently I'm a student, I'm in Portugal under the Erasmus Mundus scholarship. And then I'll be doing data engineering, I think, for a while. And also when it comes to Docker, I've been doing it for a while. So for this session, you'll be learning about Docker, and it's for beginners. Like even if you're a beginner, you don't need to be experienced. We'll be taking it one layer after one layer. So if you don't know anything about Docker, you have not heard about Docker before, you're welcome, and you will learn a lot of things in this session. So without further ado, let's get started. So let me share my screen right now. And one. Can everyone see my screen? Hello?
I can see your screen.
Hello?
Yeah,
okay. So today's topic is about containerizing data pipelines with Docker and Docker Compose. It's a little bit about me. I'm an accomplished data professional with over 3 years of immersive experience in the dynamic field of data. I share my insights on tech-related topics through Medium and I actively contribute as a technical writer to international companies. And you can contact me on LinkedIn, on Twitter, or read my articles on Medium. So first of all, before we dive into containerizing data pipelines, we need to get an overview of what data pipelines are. So basically, we have data pipelines are basically pipelines or set of instructions that extract, transform, and load. Basically, whether you're doing a batch or you're doing streaming, you have to extract from a place, you have to probably do a transform and you load, or probably just do extract, you load, and then you transform later. But basically, you have these three layers that you are going to do when you're building a data pipeline. So that is basically the overview of what a data pipeline is. You extract your data from a place, you transform it, you clean it, and then you load it to a place, whether S3 bucket, Google Cloud bucket, or Azure Blob, or anyone, or even a data warehouse. So that's basically what a data pipeline is. And what are the stages of building a data pipeline? The first is you build all components of the pipeline. And obviously, you have to test the pipeline before, and then you deploy the pipeline in production. So after building all the components of the pipeline, you extract, the transform, and the load. You have to test if this pipeline is working and ensure that it's actually doing what you intend it to do. And then the next is to deploy the pipeline in production so that users can use it. And if you are building this locally, let's take, for instance, you are doing this as a test, you probably build your pipeline on your system, you test the pipeline with PyTest or any of that testing framework that you're going to use, and then you deploy locally. So you can deploy your pipelines locally on your system. And probably you can just test it on your system and just do it locally. But what if you want to open this up to remote collaboration, or you want people to use this in production? Because obviously nobody will want to use a pipeline in your system. You have to share it with the world. You have to share it with your teammates or your colleagues or other people. So the first thing is you build the pipeline locally and with your local model versions. Also, you test the pipelines locally with your local model versions, and then you deploy the pipeline on a remote server. However, if the remote server is using a different module or a version that is different, maybe you are building on Windows and the server you're deploying it to is maybe Mac OS, there might be differences or issues with your version on your local system and that of the system on the remote server. So this can lead to issue. Imagine if you are running Python 3.10 and on the server, they have actually upgraded this server to 3.11, and some functions that you actually imported into your Python script are no longer working. So these are basically issues that people encounter or run into when they build and deploy pipelines in remote servers. So, and this basically brings us to these common memes where you say it works on my computer and people tell you, yes, but we are not going to give your computer to the client. Am I too fast? Hope I'm not. Can everybody hear me and everyone following?
Please go
Hope I'm
ahead.
not too fast.
We are enjoying you.
Okay.
Yeah.
Okay, so it works on my computer, and yes, but we are not going to give your computer to the client. So that is basically it. You are not going to give your computer to the client. And so how are you going to solve this? The first is, okay, you might wonder, what if I bundle my entire system with the configurations, the versions, and the OS and replicate it on the production server? Well, this is good, right? Just bundle your system, bundle everything. Okay, I'm building this on Windows version 11 and using this Python, this and this and that and that, and then you just ship this into the environment. So this is basically what will give you a virtual machine. So what virtual machine does is it virtualizes your system, so your OS, the hardware, and then it gives you like a way of virtualizing a particular system. So you can virtualize your own system as a VM, take a snapshot of it. So it's just like taking a snapshot of your system. So it's just like taking your system from your house and then putting it on the server. So basically that can actually work, and you can deploy as many virtual machines on your server. So you just, okay, if you're building on Windows, just virtualize a Windows system. So everything that Windows does. So if you open a VM, it's just as if you're opening a system or a computer. So, but it's actually a software that runs on your system. And then if you look at it, there's an hypervisor that kind of like virtualizes your infrastructure and also your OS. So this is a possible way of solving those issues in production. However, there are some issues with VMs. let's look at the advantage first. First, you can virtualize any operating system and hardware. So imagine if you are building on Windows and on the server, they are using Mac OS or Linux. You can actually virtualize the Mac OS environment and then build everything on the VM and then deploy it to Deploy it to the server. You can bundle your system configurations into another system and run your code and pipeline on the system. So it makes it easier for you to just take your code, take everything and dump it on one system. And with this, you won't have issues with breakage in the production. However, what are the disadvantages or the cons of using a VM? It's actually resource intensive to run it because this is what it's doing. It's virtualizing like a system. So imagine you are running like 10 heavy applications on your server, except your server is actually very, very strong. Sometimes it can actually crash. Also, the numbers of VMs to run depends on the underlying system infrastructure in production. So if the system in production is using 4 gig, maybe 4 gig RAM, you can't really deploy more VMs on the server. Also, you have to spin the right OS and environment for the production server. I think I'm echoing, I don't know, or someone is. You have to spin the right OS and environment. Hello, is someone making a sound? You have to spin the right OS and environment for the production server. So if you want to deploy something on Mac OS version, maybe I don't really know the version, maybe let's say 11 or 16 or 14, you have to ensure that you're spinning the same environment, you're spinning everything must be and align. If everything doesn't align together, there will be issues when you deploy this on your production server. So this basically means that if you're a beginner, you're just starting and you have maybe a 4 gig RAM or 2 gig RAM laptop, running a VM might not be possible. So let's look at another option. So another option is, what if I freeze the versions of my modules and install the same version on the production server? So what if what I just do, instead of virtualizing my system or virtualizing my system, what if I just freeze the versions of my modules? Like, okay, I'm installing Python 3.10, it's using SQL Alchemy, maybe 3.12, Pandas 2.1. So just do this. What if I do that and then deploy it on the production server? So what the production server will just do is just install that same version. This is actually good, right? So what are the process of this? You build the pipeline locally, you have your local modules versions, then you freeze the modules version into requirement.txt. And that is the reason why we have this requirement.txt in Python. I think in Node.js or JavaScript, you have lock.json or something. So with this, you can actually like freeze your modules into a particular file. You test your pipeline locally, and then when you deploy the pipeline on a remote server, what you just do is install the freeze requirement.txt file. That's why you just have pip install -r requirement.txt on the remote server. So basically this solves your problem. And then, or you can use a virtual machine, virtual environment, not virtual machine. So you can actually virtualize the environment. So what you're doing basically is you're just taking the subset of your environment on your system and then taking it to the remote server. So with this, whenever the pipeline is run in that same environment, what happens is it's using the same modules that you have on your local system, and this will be installed on your system. So what are the advantages? It's actually lighter in comparison to a VM because you're only virtualizing your environment, not the whole system. You're not virtualizing the hardware, you're not virtualizing the software, you're only virtualizing the environment. Just imagine a room is better than virtualizing a room. Imagine if you want something to run in a room. Instead of uprooting the house and then taking it to another place, why not just take the environment or imagine water inside the bottle, you understand? So what you just need to do is just take the bottle, take it somewhere, and then it will still work, provided you're using the same bottle, than just taking the environment and taking the building from one country to the other. However, because it doesn't account for the differences in how different OS handles Python modules. So imagine, I think there was a few days ago, I was trying to install something on Windows or thereabout, and I had to like, how Windows actually installs some modules is actually different from how Linux installs some modules. So you have to actually look at how this thing, because there's some dependencies that Windows need to have for you to install something, and Linux also need to have these before it's. So some of these issues can actually still occur even if you have freeze or frozen your own requirement.txt and taken it to the remote server. So Before we move into what Docker is, one thing we need to understand is something called Linux namespace. So the Linux namespace is useful for isolating stuff on Linux. So you can have your process identifier namespace, which isolate the running of a process or program on Linux without affecting other processes. So just imagine you are running something in isolation. You are in your room. If you're in your room, imagine if you rent an apartment and you're in your room. Whatever you do in your room doesn't affect anyone. And just imagine if you have a soundproof in your room, where even if you make a noise or if you make a sound, nobody hears you. So that's similar to what the namespace is doing. So the process, any process that is running, maybe a Python script running inside a room won't be affected, or that process won't affect other processes running in another process. So you also have the network namespace, which deals with isolating the network related activities. So if you want to connect or do a lot of connection, just imagine if in your room you have maybe, let's say, power holding company in your room. So you can power your room. You don't need external power to power it. So similar to the network. Also, you have the mount namespace, which isolates the files that is mounted, and it prevents it from working on other namespace. So you can actually mount a particular folder. Let's imagine this mount namespace mount a folder. So you can mount a folder, and this folder won't interact with other folders. So, and then you have your user namespace, which isolate the user and prevent conflict between users on a system. So it's just as if you're working in an organization. Most times, organizations kind of like isolate people. So the CEO, there are certain functionalities that the CEO can do, or that you as a normal staff can do, you understand? So similar to that, how you isolate things is actually this user namespace. So it's kind of like isolate users and prevent conflict between users on the system. It's just like when you are moving on the road, instead of having maybe people jamming each other and maybe knocking each other together, you have a place where everybody goes individually on their own path and their lane. You understand? It's just like water flowing, you understand? The water is just flowing on its own path. And the C group manages the namespace in Linux. So the memory, the resources that these namespaces use is managed by the C groups. So basically, this is how the Linux namespace and C group works. So you have your process, Python process 1 is running, Python process 2 is also running, and that Python process 3 is running. Something similar to this is like Python multiprocessing. I don't know if you have used Python multiprocessing, you know that sometimes process can run individually in different threads, you understand? So just see it as that. And if you want to create namespace, you can use this command sudo on share and then fork PID, mount proc, and then bash. And then you can check the processes that are running inside this. And if you want to manage C groups, you install these C group tools. And then the second code, which is sudo cg create minus g memory dot my process. What this is doing is creating this C group, and this C group works just for memory, manages the memory. You understand? And then you can, this sudo echo 5000 is limiting. So because the C group manages this namespace, so this C group is managing that, okay, the memory limit is 5 megabytes. And then you can execute into this. And then once you do this, and then the last one is mounting a file system in the process and the C group. So running code with C groups looks nice, and I think I will go with this. So you might be wondering, instead of using a freeze version, why not use the Linux namespace, where you just know that a code is running separately inside its own process. So everything you need to run this code is inside its own process. So let's look at a demo of how you can build a simple namespace and also a file that runs in its own process with Go. So let me pull up. Okay. Can everyone see my screen? And can you see this? Can you see?
Yes, I can see your Visual Studio.
Okay. So basically, let's look at what this is doing. So you don't need to understand this, and you don't need to understand it or cram it. What this is doing is just writing a basic Go function that's kind of like helps you to create a different process inside your Linux namespace. So you have your OS, you have your OS exec and system call, and then you have your main. So the thing is, when you run your Go, so when you do Go run, and then you put the name of the command, and then you put run, this run function will be called. And what does this run function does? This run function is just executing and calling the proc. So the proc is more like a file system that deals with processes, you understand? And then what you are doing here is you are doing a system called clone new UTS. So a unique timestamp. So you are cloning a new unique timestamp on your whenever the process runs. And also you're also doing a clone new process ID. So you're also doing what? You're trying to like create a different process where this namespace will work. And then this last one, which is the system called clone new NS, is called new namespace. You understand? So you need to also like have a namespace for this. You have already looked at what the namespace does. And then what this function child is doing is setting the host name to what is called a container. So, and then you're mounting this proc, telling it that, okay, you want to mount the a proc file in the proc directory. And basically, let's try to run this. So let's do go run hello count.go. So if you look at this, you see that this takes you to a shell. This is similar to what will happen when we go to Docker and we'll run some things with Docker, but we'll get to that later on. So when you run this, what this is doing is running this in a different process. Let's look at the host name. You see that the name is container. Let me take this back to my normal shell, and then let me type the host name. If you look at the host name here, it's saying Ido PC because that is the name of my system. But when I run this go command, you realize that this is the host name is container because if you look at this, we are setting the host name for the namespace as container. So this is basically what or how you can actually like control some processes to run independently of your system. And this can actually be of advantage because imagine you are running something and you don't want it to destroy something on your system. So with this now, if anything gets destroyed, it's only getting destroyed or it only get destroyed, sorry, inside the process that is running it. It won't get destroyed on your system. So this is basically what the namespace does and how it works. So now let's go back. Let me go back to the slide. Okay, so now you are like, okay, let's run code with C groups. It looks nice, and I think I will go with this. So one question on your mind is, how can I manage more than 2 processes running inside the C group? Because imagine if you're running a Python script inside one process, a Go script inside another process, how do you manage this? It can be a difficulty when you're trying to run these 2 processes together. So this is where Docker comes in, and basically this is where Docker shines because it helps you to manage all these processes. And basically what Docker does is just trying to create this namespace for you. So when you look at Docker, Docker is not something as, don't see it as something that is very, very difficult. It's just like creating a namespace, creating something like separate for you to run your code inside your system, inside your Linux system. So that is basically what Docker does. And that is what Docker is in a simplified manner. So let's deep dive into Docker internals. The first thing is you have your Docker file where you define where you define what you're going to do, what Docker needs to do, and then you compile it into images, and then the image is run as a container. So basically, the Go function or the Go code that I ran previously is basically doing what a container does, because when you build your image and then you run it, the container, what the container just does is create all the namespace, create the network, mount the file system, and then you have an isolated process, and you can run your ATI pipeline or your Python script inside that namespace. So basically, let's look at the internals of Docker. So you have your client, you can do your Docker build when you have defined your configurations in your Docker file, then you can do the Docker build. And then on your Docker host, you have this Docker daemon, and then it manages everything about provisioning the containers and the images. For now, just think of the images as like a skeleton, you understand? And then the container is your body, you understand? Because the skeleton the body is made up of the skeleton and your flesh, you understand? So, but you don't need to worry yourself about this. We'll dive into images and containers later on. And then you can push it to your registry or your Docker registry, and you can build, you can pull, and you can run it. So when you run an image, a container is run. So one question on your mind is, Windows and Mac are not built on Linux because Mac is built on the Unix operating system. So how come Docker can run on them? So basically what happens is there's a virtual machine that Docker actually installs. When you install Docker desktop on Windows or Mac, a Linux virtual machine is created for you, because for Docker to work, Docker needs a Linux kernel. So kernel is more like a way of, so the kernel interacts between the OS and the hardware. So when you press something on your system, maybe you're using a Linux system, the kernel kind of like, no, okay, you're pressing H, and then it sends it to maybe your screen, and you can see H on it. So basically, that is what the kernel does. It's just like a bridge between the software and the hardware. So on Windows and Mac, when you install Docker Desktop on Windows and Mac, what happens is a virtual machine is created for you, but it's a lightweight virtual machine. So it's not like the bigger virtual machine that can take space. So it's just like a lightweight virtual machine, and then you can run Docker on this virtual machine. And that is the reason why you can use virtual machine on Windows and Mac. I think on Windows, you can use the WSL, which is Windows Subsystem Linux. Yeah. So now let's build our first Docker image from scratch. So we are going into the hands-on right now. I think it's better you go into the hands-on and then you know that, okay, this is what you are doing, instead of just reading something from the screen. So now I'll pull up my Visual Studio, and then we are going to be writing this from scratch. So Docker. Can everyone see my screen?
Yeah, I can see your VS Code, but is it possible? Can you increase the fonts?
Okay. This is not increasing. Yes.
If you go to apparent, yeah, or you just do, go ahead.
I don't know why the zooming is not working. Okay. Oh, okay, it's working now. Yeah. Is it better now? Is it better now?
Yes. Are you comfortable with it as well?
Yeah, sure. I'm comfortable with it. Yeah.
All right. Thank you.
So before we would even build a container from scratch, let's look at how you build your pipeline without Docker. So in the repo, you'll see two folders. You have the pipeline with Docker and pipeline without Docker. So you can clone this, and then, so let's look at how this works. So let's go to pipeline without Docker. You have your extract. Basically, what this does is reads a CSV from a URL, and then you have the load. It loads into a data warehouse, or you can call it maybe your database if the term is too complex for you. So just say it's loading it into the database, and then you have your database engine connect. In this case, you'll be using the SQL Alchemy Connect. And then we have the name, and this df to SQL is just loading this to the database. So, and then the name of the table is employees. And then we need to specify the connection, which is the SQL Alchemy connection. And then we are saying if it exists, then we replace it. And also we are using the schema as published. So schema is more like, for those that are not aware of schema groups your tables. So when you have in your database, you have tables, and schemas group your tables into, kind of like group it as a container, you understand? So you can have public, for the public, you can have maybe raw for tables that are ingesting raw data, and you can have clean schema for tables that have been clean, or production, or anything, you understand? And index is equal to false means that we are making sure that the index is not written in, and then we have the run ETL. So we have the transform. So basically what the transform is just doing is converting all these columns, the columns in the DF to lowercase, so that we can write it into our data warehouse or our database. And then we have the run ETL pipeline.py. So what this does is it just runs everything. So let's try to run this. And for this, I'm kind of like exporting the environment variables, because here, if you look at it, we are getting some environment variables from this. So you need to run this. So for you to run this, you can just do, let me even do that so that. What's up? Okay, so for you to run this, you might need to change the executable. So to ensure that you can actually run this. So what you are going to do is this export var.cs.sh, you're going to do change mode plus X. So you're saying that you can write and you can run this as an executable. So now do change mode plus X and then write the name of the file, exports.var.sh. So what this is doing is, instead of hard coding this Postgres user, sometimes it's actually good. You don't hard code it. You have to like sometimes work with environment variables because of you're working with sensitive data and you don't want anyone. Maybe if you push this to GitHub, you understand. If I push this to GitHub now, and then instead of hard coding everything, I can just put this as an environment variable. And maybe if I'm running maybe an automation tool, I can just supply this as an environment variable instead of someone seeing my password and other stuff. So this is why it's good to use environment variables. So now when you do this, then you can just do bash export var.sh. So what this does is export this. I think I need to do source. Okay, so basically you need to use the source because with the source kinds of makes this open or kind of like expose it in the same terminal. You understand? You can actually put it in a bash RSC file and then you can source it. But for that, I'm not doing that because I don't want to make it too complex. So what you just need to do, just do source export var.sh. And what this will do is it will export this Postgres user as Postgres, Postgres password as Postgres, and then Postgres port as 5432. For this, you need to ensure that you have Postgres on your system. So with this, let's run Python 3 and run the ETL file. Okay, I need to do conda deactivates. Okay, so this Python 3. Yeah, so if you look at this now, you see that it says about to load the data into the warehouse, and that is here. Sometimes you might need to print it just to see that what you have done is working very well. So yeah, this was where I add this about, let me just change this to 2, not the about to load the data into the warehouse, and then you have the load to data warehouse function, and then you print done inserting the data into the warehouse. So basically, this is how you do or build your pipeline without Docker. So now let's go to how you can build with Docker. But before we go into how you can build your pipelines with Docker, let's build a Docker file from scratch. So what we are going to do is, instead of depending on, because before you build a Docker image, you need to depend on something. So whether you need to depend on Ubuntu or Ubuntu Docker image or something, but for this, let's build from scratch and see how this works from scratch before we go into depending on other images and then seeing how things work. So for this, there is, so now let's even build this from scratch, and then let me try to comment this out. So the first thing you need to do is you need to do a from. So what does this from does? So basically, when you want to build a Docker file, you need to specify you are building it from a place. So where are you building it from? Are you building it from an image, or you want to build it from scratch? So for this, you are going to build from scratch. So you do from scratch. So it's telling Docker that, sorry, it's telling Docker that you are building this from scratch. And what we can now do is to do something called add. So what are we going to add? We are going to add this Affine. Affine is more like a different type of Linux. So we have Debian, we have Affine, we have Kali. You don't need to understand everything about this. It's just like, let's take for instance, you have Windows 11, Windows 10, Windows 7, or any other one, you understand? So that is basically what this is doing. Basically, all of them relies on the same kernel. So we can go to the browser to download this. If you don't have this, you can just go to the browser and download, download Affine Docker Scratch image. What's this? I can't see this. There's a place. Go back to my. Okay, not just to waste time. Let me just Probably maybe I will share the link and then we can, if you want to like test it, and then but I'll build this from scratch. So let's build from scratch. So our Docker file is there. So what you're going to do is from what? So yeah, we're saying we want to build from scratch. You can actually do from an image, but we have not talked about images. So we would skip that for now. So what you're going to do is if you want to add something from your system, you can do the copy or the add. So what you're saying is, okay, I want to add this from my system. You want it to be inside this Docker container when it runs, or inside this process when Docker starts the process, or the namespace, basically, because that is what Docker does. So now you can do add what? Affine mini root TFC. So affine mini roots fs. So, and then you're adding this, and then we can just do an entry point. So what the entry point does is when you start after building your image, when you want to like run this and you want to run the container, so what the entry point does is it is what is run, or the command that will run when you start the container. So if you don't specify an entry point, when you run the container, nothing will be done. You understand? So imagine if you want to run your pipeline, maybe this run ETL pipeline that we did on the terminal. What you're just going to do is just do here, instead of putting this Python 3 on the terminal, just put your entry point as Python 3, and then what you want to do, you want to run ETL pipeline.py. You can also use the command. In the next, later on, we are going to see the difference between the entry point and the command. But for now, just see the entry point as something that is run. Just look at it as entry. So imagine you're entering something. So what happens when you're entering an apartment, or just imagine someone is telling you that once you enter this building, do this. So you know that the command I'm going to do is whenever I enter this building, I'm going to like maybe open the door, or when you open the door, something like that. Or when you enter this, someone can just say that, okay, when you enter the building, once you enter this building, do this. So that's basically what this entry point is doing. So just see it as if you're entering something, and then the point of contact, you understand? So that is it. So now what you're going to do is we already have our Docker file, and then here we are going to build the image. So the first thing you're going to do is first build the image, and then you run your container. So you need to build the image first, so before you can run your container. And we'll see why we need to build the image first before we run our container later on. So now we are going to do a Docker build. So you want to build your image, Docker build. You need to tag your image, or give it a name, because imagine you don't just want to have your image as none, you understand? Docker doesn't know what none is. So you do Docker build tag. You can do this as -2 and tag it, but for shortcut, you can just do one hyphen and then tag. Then you can call this, let's call this scratch image. Scratch image. And something else you need to do is you need to tell Docker where you are building, or where the Docker file is. You understand? In this case, our Docker file is in this directory, so we are going to put a dot. So what this dot does is it tells Docker that the Docker file is inside this directory, and it doesn't need to look at a different directory. Imagine if this Docker file is inside, let's say, this pipeline with Docker again. What you are just going to do is dot and then put the name of the directory, and then Docker knows that, okay, this Docker file is inside this directory. And by default, you need to name it as Docker file. You can actually have a different name, but I think you need to, if you are going to specify a different name from Docker file with D capitalized, you need to put -F to tell you that, okay, Docker knows that, okay, you are referring to this file with a different name that it knows, because by default, when you specify this Docker file, Docker knows that, okay, this Docker file specifies the instructions that I need to do. So now, given the fact that we're inside this directory, what you're just going to do is do your Docker build -t, which is tagging and scratch. So what this is doing is Docker build, tag this build with this name, which is scratch image, and then let's run this. So one thing you are going to see is from here, you are going to see something here, transferring Docker file, loading data, metadata, and then this is caged because I've actually run this before. You understand? I've actually run this before, and that is the reason why it is caged. So you can do Docker build, I think no cage. Yeah, I think if I'm right. Okay, so and this would build this and load it again. So what you are seeing here is it's exporting the layers. So we'll look at what layers are in the next slide. But what basically happens is when you build your images, Docker builds this in layers. You understand? So the first thing is, because you are specifying this from scratch, Docker won't build this as a layer. But when you add this, Docker will take this as what? As a layer. And we can do something here. Let's do Docker inspect. So we want to inspect this image that we have built, test. So one thing you are going to see in this Docker inspect is, first thing you are going to see is you have your different layers. And these different layers, they correspond to the different operations that Docker is going to do, like your add, and other instructions. Or even if you're going to do a run, maybe you're going to do run a command inside this directory, what will happen is Docker will also take this, because what Docker is doing is it's taking a snapshot of, at each time when Docker does add, when Docker adds this affine mini root into the Docker folder, what happens is it takes a snapshot and tag that as a layer. So this is how Docker manages the layers. And in case you want to run it again, imagine if you run this again now, let me run the build again. You see that it's faster because Docker has already cached some of these layers. You understand? So it takes the snapshot. So when you run, maybe run APK, let's say APK add no cache bash, or do any other stuff. Let's even try it and see. So do something, cat Docker file. There's an issue. Sorry, I think this is not picking this Docker file, because this should be a different directory. Oh, I see. Let me move this. I see. And I realized that there was an issue. Let me move this. Move. Okay, let me do something. Let me copy this and paste inside this. The reason why I realized that there was an issue was because if you look at this, it's telling us that working directory, and here we didn't specify a work directory. So it shows that it's using a different Docker file. So I've kind of like modified that. And then now let's review this. Docker build -t crash image, no cache. Okay, so here we need to move this inside this directory. So move. Now let's run this. Oh, this is 3.10.3. So let me take this out. Okay, so now let's look at this. This is the scratch Docker file. It was actually pointing to a different Docker file earlier on. So now this is the scratch Docker file, and then let's do a Docker inspect. The Docker image ls scratch. Okay, Docker inspect scratch image. Yeah, so here, if you look at this, we have one layer. Remember when I ran this Docker build with a different Docker file that has the Python, I think it had a Python copy or something, you realize that there were different layers. But here we only have one layer. Why? Because this scratch is not a layer, because you're telling Docker that you want to build this from scratch. You don't want to rely on a dependent image. So you're telling it that, okay, I want to add this. So what this is doing, remember when I specified 3.16, it was not adding because 3.16 doesn't exist here. So when I change it to 3.10.3, so I think even running into errors, you kind of like see how this works. And instead of just seeing something working from scratch and then no errors and nothing, and then you don't even understand what's happening. So with this, you can see that when I add 3.16 or 3.16 here, it won't work because I don't have 3.16 here. So because it's copying this. So we can see that the add or the copy is just taking what is on your system and putting it into the Docker container. So now when I put a 10, it can see this and copy it. And that is the reason why you have one layer. So when you add this, Docker takes a snapshot of that directory and see that, okay, this has been added. So imagine, let's add something else. Let's add and see how the layer increases. So let's add export. Let me just add load.py into this. Now let's review this and see the layers that Docker. Okay, now let's do Docker inspect again. If you look at this now, can everyone see my screen? Hello?
Yes, yes.
Okay. Yes. So now if you look at this, what happens? We have two layers. Why do we have two layers? Because we have added two files. The first was this affine mini root. And when we add a file, this is how Docker tries to like manage all the layers. You understand? So when you add one layer, Docker takes a snapshot and then shows you that, okay, this is the first layer. And then you have another layer, which is load.py, because you have added another. What is happening is you have changed something. You understand? When you add a file into something, what happens? You have changed. Imagine if you had a file, if you had two files in a particular directory. When you remove one or you add another file, what happens is the properties of that directory changes. You understand? So what Docker does is it's just like managing the properties. You know that, okay, there is a change. What happens? We added a load.py. So now let's rerun this Docker build and see how fast it will be. Let's remove the no cache and see how fast it is. Can you see how it is fast? Because Docker knows that, okay, you have not done any modification. So what happens is Docker just reuse that same layer. And then now let's try to run this. Let's do Docker run. So you build the image and then you run it. So Docker run scratch. Let me do Docker run scratch image. Okay, sudo mouse. What happened was because when I ran this container.go, what happens was the proc file was loaded into the process. So it's now when I try to run the container, Docker doesn't know how to run the process. So that is the reason why there's an issue. So now what I need to do is to do a mount. Sudo mount proc. Safe. Okay, just hold on, please. Just give me a few minutes. Let me try. So sometimes you are running into issues, and that is the beauty of things. So, okay. So I need to mount this process back. So you just give me a few minutes. Okay. Let me run this back. Sudo mount -t proc and then proc and proc. Okay. So exit. Okay. Now let's try to run our. So now when you do your Docker run, you see that the hello world that you specified in your Docker file is actually printed because that is the entry point. So why I did this sudo mount was because, remember I said when I mounted the, look at the go, where's that go file, so that you see what occurred in case you run into the same issue. Yeah, this code, you realize that we call the proc here. Let me do this. Stop. Okay. Yeah. So if you look at this here, we did the proc here. So when you mount it, you are mounting it into the process. And if you try to run another container outside, Docker doesn't know all this, or Linux doesn't know how to handle the proc, because the proc file handles the processes. And that was the reason why I had to mount it back. And with this, now once you mount it back, everything will work back. So let's go back to our slides. Okay, so now let's build and run your first Docker image with dependencies. So now let's build, this one will be hands-on, and we actually started the hands-on. So now, and this one will be writing it from scratch. So let me take this out. Replace. Now let me write another Docker file from scratch, and then this will write it together. Docker file. Docker file already exists. No, cancel. So now let me do ls. Okay, so let's write this from scratch. We can use the editor. For this, I just want to use the nano. So now let's do from. We want to like run this from the image. So before we built this from scratch, right? So we built an affine image from scratch. Now instead of building this from scratch, you want to like just build this from an image. So you need to specify your from. So your from is like telling it which image. So basically, there are some pre-configured or pre-configured images that people have built in the past, and they have uploaded of Docker, just like GitHub, where you can publish code and the rest. So we are going to like depend or take from that instead of building this from scratch, because if you want to build, maybe want to have a system that has Python installed, Ubuntu installed, and other stuff, then we need to do from Ubuntu. We need to install Python on the Docker container and do a lot of things. But instead of doing all those tedious work, someone has already done it for us, and they already have the image. So what we're just going to do is build off it. It's just like you are building based off something. You understand? So you're not building from scratch. You are building based off something. So for this, we are going to use Python. So there are images. This image contains Docker image of Python with Ubuntu. And for this, pipeline with Docker file. So here we are going to use the Python 3.10 bookworm, which someone has already built for us, and we don't need to rebuild it, because what this does is it gives you an image of Python and Ubuntu, so you can run any other thing and continue from this. So it's just like, okay, start from here instead of starting from scratch. And then we need to have a working directory. It's kind of like best practices to use the working directory, because that is where your code will run and stuff like this. You don't want it to run in the root, you want it to run in a particular directory. So you have your work directory. So this is like working directory where the code that you want to run, where you want Docker to run this code from. So by default, it is app. You can call it any name, you understand? And for this, let's copy the extract.py, copy extract.py, and let's put it into app inside the directory of what app with extract.py. And then remember, what are we going to do? If we want this to run, we can do an entry point. Entry point. Entry point. Entry point. Let's call this bin echo. Let's just call this inside, or let's call it inside Docker. So what happens is, remember, the entry point is your first thing that Docker does once it has built the image and it's about to run the container. So let's save this. Yeah, we should have a Docker file here. So now, for those that are building or following and writing this, so what we are doing is we are doing from. If you look at this, it says set the base image to use for subsequent instructions. You understand? So what we're just telling Docker is, okay, we don't want to build this thing from scratch. We don't want to install Python. We don't want to install Ubuntu. We don't want to do a lot of all those tedious stuff. We just want to use something that someone has built. So what this is, someone has already helped us to build an image of Python. They have installed Python on it. They have installed Ubuntu. They have installed things that we need. And then we can now continue from this. So now you have your work directory, which is app. And then you can copy this. So remember, we use add. You can use the add or the copy. But the difference between the add and the copy is the add kind of like gives reference to your, when you do add extra.py, there's a reference that is linked to your system. But when you do the copy, copy doesn't give a reference back to your system. You understand? So copy just copies it and that is all. But the add still kind of like link this Docker and container to your system file that you use to add. Now let's build this as our, let's do Docker build -t, which is a tag. So this is Docker build -t, and then let's call this our first image. And remember, what are you going to do to build this? You need to specify what your Docker, your build, your tag. So if you look at some things here, you look at this. So this is Python image. You can also keep this tag as latest. Something that you can do again is do latest or the version of this. Sorry, this should not be here. So you can do your latest and then specify. This dot is telling Docker that the Docker file is inside this, and you should look at this directory to build this. So now let's build this from scratch. Okay, bookworm, sorry. So we have already built our images. And if you look at this, one thing you're going to know, or let's do Docker inspect. So let's see, or let me copy more than, let me do something else. Let me copy load.py. So app.load.py, then let me copy transform. So now let's build this again. So building this again. Now let's do Docker inspect for you to see the layers that Docker has built. So Docker inspect, first image. So now let's see, we have different layers. Why do we have a lot of layers? Because this Python 3.10 already contains some layers in the image. Similar to, imagine, we remember when we built this from scratch, when we use the scratch Docker file, we had some layers already. So now if you were to use this scratch image that we built and someone else is using it, there will be an additional layer. You understand that Docker will also include, because you are already taking layers from another image. So that is basically why we have a lot of layers. And this is basically what Docker does. So remember, the layer is just like a snapshot. So when you copy extra.py into this, Docker takes note of the current state of your directory, or the current state of, let's say, the process or the environment, and sees that, okay, you have added something. And then when you add another file, it knows that, oh, there is another modification which is different from the previous step. So this should be another layer. You understand? So that is it. Now let's go back to our slide. So let's make changes to one of the files in, let's just make changes to this extra.py. Let's just do something like imports requests. Let's just call this import request. And now let's rebuild this and see Docker build. If you see what happens is, now let's go back to our Docker file and for you to understand what happened. I think in this extract, right, what did we do? We made a modification. So what's Docker? Docker is also still smart to know that, okay, you have made a modification to this. So there's a difference, you understand? So before, if you did not make a modification to this, Docker would just use the cached file. But now when you made a modification to it, Docker would do. So one best practice when you are writing copies, sometimes things that you are going to modify, you put it under, like what you're going to do is, imagine if you're going to modify this extra.py always. So you are going to Control X and then paste it here. Why? Because if you modify anything above any layer, Docker will run from that layer downward. You understand? So if you make a modification to this load.py, Docker will run this load.py and also run this again and also run this again. Because they are layers, you understand? And if the down layer is corrupt, let's imagine something is corrupt on the down layer, and imagine if the other layers depend on it, you are going to like corrupt everything. So now let's do Docker history for us to see something. Docker history, first image. So now let's look at what is happening in the Docker history. So look at it. One thing is, you see here is from down is from Python. We are taking this from this Python. These are the images, the size, and then we are adding some files, and then here all these layers, they correspond to the Python 3.10 bookworm image. And now here we are coming here to copy extra.py. So if you look at it, this is the size of the image. I'm sorry, the size of the file. And then the copy load.py is also, this is the size. And then copy.transform, this is the size. This entry point is just a command. So this is not, it's not making any modification. You understand? It's not making any, if this bin.echo is like writing or piping to extra.py, then what will happen is Docker will also create a layer for it. But the reason why Docker is not creating a layer for this or without a size is because this is just a command. The command is not making any modification to the files inside your Docker container. So now let's go back to the slides. Like we have made changes to this, and then we have look at the Docker history. So now let's look at something about the overlay system and why, or one of the core concepts behind Docker, which is the overlay system. Sorry. So one thing is, when you did the Docker inspect, one thing you are going to notice is you see something here. Let's do Docker inspect first image and see something here. Docker inspect first image. If you look at something here, you see something called the met directory. You have something called the upper directory, and you have something called the work directory. So what happens is, when you build your image, the images are in the lower directory. You have the lower directory, which are these. Now, when you run the container or when you run the image, Docker will move all these components inside the lower directory into the upper directory and the work directory. So any modification that you make it will only be affected in the upper directory of this Docker instance or this Docker image. So that is the reason why you can run multiple images and make modifications and do a lot of things, and there won't be any issue. So let's do something. Let's okay. What I wanted to do was to remove some things from here, and then we'll see that there's no issue. Okay, now let's do something. So now if you look at something here, you have the main directory, you have the upper directory, and you have the work directory. So when you do any modification in the container layer, what happens is the image, there won't be any issue. Now let's do something. Let's even do bin remove. I guess I should be able to remove. I guess this should work. Let's do remove app.extra.py. Let's do something. App.load.py. So let's see something and see that, or see how Docker manages images and containers. I hope this bin remove command will work. So now let's do something here. Let's review this. Okay, now let's run this. Docker run first image. So here, what happens is this entry point will remove this load.py. But let's run this doc and this load.py. I'm trying to do something here. Being remove app.py or okay. So now let's look at this. If we run this, let's run this again, and let's run this again. So Or let me do something, being remove, being echo. This will also work. Being echo being echo hello. So let's review this image and let's run this and see if it will work. Okay, Docker run requires just Docker run first image. Okay, so now being remove cannot remove hello world. What I was planning to do was to remove this and run this again and see how it works. So, but probably it might not work now. So let's go to understanding how the overlay works. So what happens is the overview of the overlay system. By default, when you build your container, when you build your image, you have your lower directory, which contains all the files in your, that Docker has already gotten together, you understand? And then you have the upper directory, and then you have the upper directory is where when you are running the container, the upper directory is where this works, and then you have the merge directory. So if you make any modification, if you delete a file in your Docker container, or let me even do something. Okay, maybe I'll do that later. So when you remove any file or make any modification to your file in your container, what happens is that file will be deleted in that container, but it is not deleted in the image. So you can still run that image again, and that file will be present. So that is basically what happens. So let's even do something. Let me see if I can do that. Entry point being removed, upload.py, being bash. Let me see. Let me remove an entry point and see. Let me leave the entry point. So let's do something here. Let's do Python run AC, and let me review this. What I just want to do is we are going to want to exec into the or go into the container. So let's run this. Can't open the file, upload.py. Let me do something. Command Python load.py. Okay. So let me view this again and run this. Okay, no module called Panda. So now let's do something here. Let's do run pip install pandas. Okay. So Docker run first image. No module name pandas. Or let me do something. Oh, I need to review this image. So let's review this image. So we are pip installing this. And instead of this, let me also copy the run ETL pipeline. So now instead of running the load.py, let's run the run ETL pipeline.py. Okay, for this, I think I might also need to have the SQL Academy, which should take a lot of time. So let me just go back to the slide. So basically, the core concept behind Docker and how it manages images and container is the overlay system. So you have your lower directory, you have the upper directory, and then you have your merged. So for the overlay system, your lower directory specifies the files in your image. So when you build this, when you do your Docker build, all these files are in your lower directory and they are in the image. And if you do in your container now, your container, all these files, when you do a Docker run, the files in the lower directory will be shifted to the upper directory, and you can do any modification on it. And then once you have done your modification, Docker will merge it into a merge directory. And that was when you did the Docker inspect, you saw the lower directory, the upper directory, the merge directory. So if you delete anything from the upper directory, in the merge directory, you will see that it has been deleted. But in your lower directory, it's not that deleted, because what the upper directory just does is copy the files from the lower directory into the upper directory. So now let's do a simple demo of how the overlay system works. And I've actually uploaded something on GitHub. I think you should see this overlay test folder. So this overlay test folder has a script which creates the overlay directory and creates the upper directory, creates the work directory, and also creates a lower directory also, and also creates a client one. So client one can be seen as the container one, and client two can be seen as the container two. So if you have this clone, just go to your VS Code, and I already have it in my system. So for this, let me even delete this, or let me just copy this, copy, and then have another folder. Called, let's just call this overlay test new. And then let's copy this here. Yeah, so this is an overlay test new. So now we're going to create something similar to this. We are going to make a client directory one. Inside this client directory one, we have an upper directory, we have a work directory. Inside client two, we have the upper directory, we have the work directory, and we have the lower directory. So this should be lower directory. So just ensure that this is lower directory. So you're going to do your make directory, lower directory, and then your make directory merged. So this merge would take information from the lower and the upper directory. So now let's run this. So cd, cd out of this ls, cd overlay tests, cd overlay test ls. Now let's cd into overlay test new. So now here we have our create directory overlay sh. So we can just do bash create directory overlay.sh. So here this will create your client one, your client two, your lower directory, and your merge directory inside the overlay test new. So now let's try to mimic what Docker does. And let me pull up my slide here. So now what we're going to do is run this command, echo data one into lower directory file one. So Control Z, Control C. So now let's go here. Inside the overlay test new, do a paste. So what we are doing is we are echoing. So this is basically we're trying to like see how the image works. So now let's go back again and also copy this, echo data 2. I'll be fast with this because of time, paste this. And then the last one is what we are echoing into this. So this. So once you run this now and you look at your lower directory, you realize that you have file 1, you have file 2, and you have file 3. Now let's use the overlay system. So what you're going to do is mount, you are going to mount overlay, and then you're specifying your lower directory as the overlay test, that's called lower directory. And then for this, you need to put, because you're inside the current directory, you need to ensure that you need to put a dot before this backward slash. So now let's copy this. Copy. Let me see if I can paste this. Okay, Control C. So now let's paste this. So what we are going to do, because we are inside the overlay test new, so what we are just going to do is we are going to do something here. Because we are inside this overlay test new, we are just going to do, we specify that we are specifying the lower directory as the lower directory inside this current directory. And then the upper directory will be this. So it will be this, and then what will happen again? This will be, can remove this overlay test. If you are running this as outside overlay test, then you need to ensure you do this. So now remove this. We are running this inside, so we just need to specify. What happens is, for those that are not conversant with Linux command line, your dot and your slash is saying, let it look at the current directory. So now let's run this. So it must be super user to use mouse. Oh, okay. So let me sudo su. Okay, so let's rerun this. Let me just copy this. Copy and paste this. Okay, so we have already created for lower directory for client 1. Now let's do for client 2. So client 2 is like a different system or a different, what's it called? a different container system. So let's copy this and run this here. And we can even do tree and see how things are. So here you can see tree. One thing you are seeing here is in your merged, you can see that client 1 has already been merged inside what? This file 1.txt in the lower directory has been merged into client 1 because you said it's overlay. So what overlay does is you have the lower directory. It knows that, okay, because you have already written that overlay stuff, it knows that, okay, the files in lower directory should be taken into the client 1. When you look at the code, see, it says mount overlay, lower directory is this, upper directory is this, working directory is this, and the merge directory is client 1. So it will copy the files in the lower directory into this. So basically, this is what happens when you run a container. So the images has all the files, and then when you run a container, the files inside this image is transferred into the upper directory or the merge directory of the client 1. So now let's do for client 2 and see how this works. Now let's do for client 2, paste this. Remember, you are going to change. So here it will be .this, .this. I'll try to be very fast because of time. But basically, the main aim is for everyone to understand what's happening behind the scene, because once you understand what's happening behind the scene, then to write a Docker file will be very, very easy. So now let's do tree and look at the file structure. Now you see that client 1 and client 2 already have their merge file as the content of the lower directory. So now let's make some modification to, let us modify the files in client 1. Let's even remove the files in client 1. So let's go here, client 1, in the upper directory, in the work directory. Okay, let me do something here. Okay, let's do a modification. Let's just do echo. Let's do an echo into client 1 files. So now let's do echo. So for you to see how this works behind the scene. So now let's echo data 2, or let's just echo data new. Remember, we only have data 1, data 2, and data 3. So now when you, and we are piping it into client 1 into what? Client 1. Yeah, to client 1. So into, that will be the upper directory of client 1. So client 1 underscore file 1.txt. Let's see. Client 1 file like that. So let's echo it into the merged. So now merged file 1.txt. So now let's do cats of this. cat of merge file 1.txt. So if you look at this now, this is data new, but let's look at merge of sorry, this should be, so this is an error. I should have echoed this into client one, merge underscore client one file.txt. Okay, so now let's do a cut of this. So the merge is telling you that, okay, this is the container, and then, so you see that data new, but let's cut the files inside client two. We see that the files inside client two is data one. So if you make any modification in your container, if you have two container that is running from a single image, and you make a modification to that container, the other container won't be affected because they are in a different process. So this is basically how the overlay system works in Docker. So here, your lower directory is your image, and it contains all the necessary files that you need to run the container. And then when you run a container on it and you make any modification to the files inside that container, it won't affect the lower directory. So now let's look at, let's cut lower directory file 1.txt. What happens? What are we seeing? We are seeing data one. So whatever you make, any modification you make in the merged directory won't affect the lower directory. So this is basically how the overlay system works. And this is what Docker uses behind the scene to manage all this stuff. So you can have thousands of containers running from the same image. You can even delete all the files in your container, and the image files won't be affected, because what happens is when you run the container, the lower directory, the files in the lower directory is transferred to the upper directory of the container or the file system. So basically what happens is Docker is just, you're working with file system. That is basically everything. So now let's go back to our slide, and I'll try to be very fast. Now let's do our hands-on to build our ETL pipeline with Docker. So we're almost getting to the end of the webinar, and here we are going to the hands-on practice of building ETL pipelines with Docker. Can everyone still hear me? Hope I'm not too fast, and hope everybody is getting it. And I don't want to be too fast. I hope everyone, hello, can everyone hear me?
I can hear you loud and clear. Yeah.
Okay.
You can see some reactions already. So please go ahead.
Okay. So now we are going to do our hands-on practice of building our ETL pipeline with Docker. So now this is the time we are going to build our ETL pipeline with Docker. So now you know what Docker is, you know how Docker works, and you just know that you're just building this inside a process. And what container is doing is just provisioning a process where you can run your files and stuff like this inside your Linux system. So I already have this on my system, but I will move it to another side so that we can do an hands-on. And we're going to like write this from scratch. I don't just want to read it for you and then you just see it. I can make mistake. It's better because when you make mistake, you learn from it. And that is the beauty of doing hands-on than just recording something and showing to people, because when you record, everything is perfect. So now let's go into our pipeline with Docker. So here we have our Docker file. So what I'm going to do is I am going to remove this and put it in pipeline without Docker again. Okay. Do you want to replace this? Let me replace this. So now, what are we going to have? So let's move into our pipeline with Docker. So we need to have our Docker file. Remember, the name should be Docker file. It can be any name, but by standard, it's just by standard, just use Docker file, decapitalize. And if you look at it on your VS Code or any editor you are using, it will show this Docker icon. So now the first thing we are going to do is from what? We need an image that has already been pre-built for us. So we don't want to build from scratch. You can actually do from Ubuntu, because Ubuntu is also a base image. You can build from CentOS, you can build from Kali. So this is not building. Sometimes another question that might come into your mind is, am I provisioning an OS? No, this Ubuntu is not a VM. This Ubuntu is just the files that the kernel will need to work with. So remember, when Linux is the different varieties of Linux versions, what they just do is they have their different applications, but they have the same kernel that they work with. So whatever makes you, or the only thing that ensures that you are a kernel or you're a Linux distributor or you're a Linux OS is the fact that you can communicate with the Linux kernel. You can be Ubuntu, you can be CentOS, you can be Kali, you can be anything, you can be any name, but provided you can communicate with the Linux kernel, it can be any kernel. You can, as provided you can communicate with the Linux kernel, that makes you an Ubuntu variant. You understand? So, but for this, we are not going to do from Ubuntu so that you won't get confused. But you can build from Ubuntu. You can even build everything from scratch. You can say, okay, from scratch, remember what we did from scratch, you build everything from scratch. But now you can also say from Ubuntu. So what will happen is you have an Ubuntu environment, and then you can now build on it, just like a scratch Ubuntu OS when you install Ubuntu. So now let's do from Python 3.10 bookworm. So here you can also have Alpine. Alpine is another type of Linux system. So we're going to use bookworm. So bookworm is built on Ubuntu. So you need to specify your work directory. You can choose not to specify it. You can say this as app. Sorry, I have autocomplete, but I don't want to do autocomplete because I want everyone to see it as you are writing it. So we want to copy. Remember one thing, one of the best practice when you're writing your Docker container, when you're writing your Docker file is ensure that files that you're not going to modify occasionally should be specified up. So here we are going to copy our requirement.txt, and then we are going to put it in our app requirement.txt, because obviously we won't be modifying the requirement.txt, and that's the reason why we are putting it first. And then we can run pip install. So here, so one thing you need to know is, I remember when I was trying to learn Docker, one thing that helped me was, whatever you are doing, see it as if you are running a program in your Ubuntu system. So normally, what are you going to do? You are going to do a pip install. Normally, if you have a terminal of Ubuntu, you're just going to do pip install. Just know that you are going to use a run. So you are going to say, okay, I'm running this inside this. I'm running a command. What do you want to do? You want to copy this. What I want to do, I want to run this. So just do run pip install. So see it as if you are doing anything in your in your Ubuntu stuff. Then we are going to copy exports. For this, I'm not going to do the exports. So we'll see how we're going to run this. So it's a pipeline, and then copy extract.py. So what you're just doing is you're copying the files here, extract.py into app.extract.py. Then we're also going to copy. But one thing is, every copy or every run operation you do builds up a layer for you. You understand? Remember when we did the Docker inspect, you saw the different layers inside this Docker container. So now when we are going to do our transform.py and then put it in app transform.py. To make this better, let's order this, because remember, let me order this. You need to have your extract before you transform and then run. And then we can do a command. So here we're going to see the difference between this command and entry points. But after running this, we're going to see the difference between your command. Or let me even try that so that you see the difference between your command and entry point. So basically, the command is also something that runs when you start your pipeline. But what happens is, when you do the command, the difference between the entry point and the command is, when you do a Docker run and you specify command in your Docker file, if you specify any other thing after the run, Docker will ignore this. Docker will ignore this. But if you use the entry point, any other command that you have after the run will be appended into your run. So I know this is theory. Now let's go to practical and run this. So Docker file. Yes. So let me call this command cmd. Now let's go to, where is this located? It's in my Docker webinar. So cd, okay, ls. So now we have a Docker file here. So we are doing the command. Now let's do docker build -t and let's just call this cmd entry, just any name, and then specify where you are. Let me just remove this and let me do from Python. Let me just copy the file that we have here. This is just a test one, and then let's just put this here. So now, and let me even remove this. This is just a test, so let's run this again. So it's building this. Now let's do a docker run. Docker run cmd entry. Now let's do something. Let's say I'm specifying bin echo, and then I say me. When you run this, what happens here? You see that me is printed on your screen. Why? Because Docker ignores this bin underscore echo hello. Now let's change this to entry point and see the difference between this, and let's change this to entry point. So entry point. Okay, let's review this. Now let's run this. One thing, what are you going to see? What you're seeing is you're seeing hello, bin, echo, and me. Why? Because entry point would concat any other thing. Let's even remove this bin echo. Let me just do me. So what are you seeing here? You're seeing what? Hello, me. Why? Because entry point will concat, or what is concat? For those that may not understand what concat is, concat means you are joining it together. So what will happen is bin echo hello join with me would be joined as the command. Please let me take water. Okay, so this is the difference between the entry point and the command. And as a best practice, Docker recommends you to use the entry point, because if you don't want anything to overrun, or imagine if you are writing a query that runs something, or you are running a pipeline that maybe starts a particular process, and you don't want, when you run the Docker run, you don't want it to be overridden or override, then you can use the entry point. So now let's go back to our pipeline. Yeah, so, okay. Was it this one that was? Okay, yes, I was showing the difference between the command and the entry point. Now let's go back to the entry point, because entry point is better. So not really like better, but you won't override your command that you have specified here if you use the entry point. So let me go back to my CD pipeline Docker CD ls. Okay, now let's do Docker build. We're almost getting to the end of the webinar, so let's call this ETL pipe doc. And then what are you going to do? You're going to specify that you are building this from the current directory. So Docker will only look for the Docker file in this directory. Copy, run ETL pipeline, not found. Why? Oh, sorry. Run ETL pipeline.py. Yeah. So, okay, now let's run this. So while installing this, so as you can see, it's just as if you're installing something on your terminal. And the run is just like saying, okay, you want to run a command. So whenever you want to run a command, you need to put the run. But if you want to copy anything, you need to put the copy. Although there are some things about security when it comes to copy and other stuff, but that should be maybe for later advanced concepts. So now let's run this and say Docker run. And what was the name of the, okay, ETL pipe doc. No module name load. Oh, sorry, I need to copy the load. Copy, load, .py into load.py. So let's review this and run it. Okay, let's run this. Docker run etl pipe doc. Okay, so what is happening is remember when we did the pipeline with our Docker, what happened was we exported the environment variables. So if you want to ensure that Docker takes those environment variables, what you're going to do is when you're running it, you're going to specify your environment variables as this. So I will just, let me go back to this. So here, what you're going to do, what this is doing is taking the environment variables from this. And that was the reason why I did a spotting, because it will be kind of tedious for me to keep writing this and repeating this. So here, what we are doing is taking this Docker run, the name of the Docker container. So one thing I forgot to say, sometimes you can also give the name of the Docker container when you run the image. If you don't give a name, Docker will randomly give the container a name, any name. So now you can specify the environment as Postgres user and then the different environment variables. So with this, whenever the Docker container is run, what happens is this environment is inside the container, inside that container environment. So I'll just copy this. Because of time, I don't really want to type a lot of things. So I'll just copy and paste. But in your free time, you can type it. So basically what you're saying is Docker run. This E is telling you that these are environment variables that you want to be present in the environment. So, oh, sorry. I need to give it a better name. The name of the Docker image. So what this is doing is giving the environment variables, and then you're saying, okay, and then what's the name of the ETL pipe doc? So I'm going to put the name of ETL pipe doc. Five, 4, 3, 2 already in use. So let me bind this to 5, 4, 5, 4, 5. We'll talk about port later on and we'll see how it works. So let me give it a different container name. What it's saying is because we have already, the thing about Docker is if you create a container, even if it doesn't run, Docker will already provision that container. So you can do Docker intro container new, and then let's run this. I hope I'm still within my 1 hour, 30 minutes. So just try to rush this. So now, invalidate for int with base 10, post. Postgres ports. Okay, I think for this, let me just specify it as 5432. 5432. So why are we specifying all this directory? So I need to give this another name again. I'll try to be fast with this. Let's call this another new again. So let's try to run this. Let's run this. Oh, sorry, there's an issue here. I should do up. Remember, we already specified our working directory. What was happening is I didn't specify the correct path, and that was the reason why it was failing. So let me review this. And then we run this again. So I can remove the container, but that might be later on. Why I'm specifying a new name is because of the container variable search file or directory. What's happening? sorry, let me do something. Echo CSV URL. Wow, CSV URL is not being. Okay, I think I opened a different batch, so let me rerun this. Okay, pipeline without Docker. Pipeline without Docker. So let me do source so that the environment variables are present. So let me do source export. Okay, now let's go back to with Docker. Okay, so now let's run this again. But in this case, you need to give this, or for this, let me just remove this Docker PS. Docker intro container, Docker remove, plus Docker remove, Docker PS minus AQ. Okay, so now we can use our name. Now let's run this. Okay, so this was the error I was waiting for. So the error is saying what? That it can't connect to the Postgres server. Remember when we ran this pipeline without Docker, what happened was we were inside our local system and our local system could talk to the Postgres server. But right now, we are inside a different process. And now you see why an how Docker kind of isolates stuff. So we're inside a different process. You understand? So now we're inside a different process and we can't connect to our local Postgres server because they are inside different processes that doesn't communicate. They don't communicate. And that is the reason why it's telling us that it can connect to the local server at local host. So what we are going to do is what we are going to call the network. So let's go back to what's network. So to fix the error, we need to have a network and we need to create a network, a Docker network. So what the Docker network does is this. So here you have your ETL Docker image, and we are going to also pull a Postgres image again. So for this Postgres image that we are going to pull, we are going to put them inside the same network. So that is what Docker does. So with this, they can actually like communicate with each other because by default, the containers run in different processes and they can't communicate with each other. So Docker, with Docker network, these two can now communicate together. So after this, I think it's Docker Compose, so then we can wrap. So now let's do a Docker network create. So the syntax is what? Docker network create the name of the network. So now let's go here and create a network. Let me even go out of the sudo. Okay. Sudo pipeline out Docker. So let me also do source exports var.sh. Okay, now cd pipeline Docker. Okay. So now we are going to do a what? Docker network create. So we can call it, let's say, webinar network. So now when we are going to run our Postgres container or our ETL container, we are going to specify another parameter, which is the network. And how are we going to specify this parameter? We are going to specify the parameter with this, with a -- network, and then you are going to specify the name of the network. Okay, so now let's rerun our Docker image ls. So we have our ETL pipe doc. So now to run it, we have our command, right? We have our Docker run. So here, but before we do this, because if you run this now, this image you try to, or this container will try to find the Postgres host. So what we're going to do is to run a Postgres container first. So for that, I think I have a script where, I guess I have a script for this. So inside our run ETL pipeline, I have it inside this. Let me check here. I just want to copy it so that I don't type it and it takes me time. Okay, so yeah, let's just go to the Docker org and search for Postgres image. So Postgres official image, and then we are going to do a Docker run with Postgres, and then you need to specify your environment variables. And the environment variables are the Postgres password, Postgres user, and the Postgres DB. So let's do that right now. And before, while we are running it, we also need to specify that we, there's a place where I specified this pipeline with Docker again. Let me go here. Guess I have this inside this. Okay, it's not here. So now we need to run our Postgres image. So let's do Docker run. And for this running, we need to specify our environment. And our environment are what? Environment here from the Postgres tells us the Postgres password. So here we are going to put this password is equal to what? Let's call this the password that we use here, which is Postgres. And then he again, Postgres user. Remember, these are the environment you need to specify here. Postgres user, and let's go back to this. Postgres user is what is our Postgres. And then another environment variable is our Postgres database. So it's Postgres DB. Let's call this Docker workshop. And one thing you need to do again is to expose these ports because by default, the port of Postgres is not open. So we need to open the port with this flag. So 543, let's say 543, 5432. And then we are going to, for this, we need to specify the name. Yeah, so we need to specify a name, Docker run name. Let's call this Postgres DB. Why are we specifying the name? Because this is what we are going to use for the host. So now we can do P5435. By exposing, what we are doing here is exposing the port. So basically what port does, for those that may not know what port is when you're connecting to a particular server, you need to it's just like your socket, right? When you want to connect or you want to transfer something, you can't connect HDMI to a USB port. It doesn't work. So the HDMI port should be connected to the HDMI port on your laptop for you to have a connection. You might have the wire, but if the HDMI port is not on the system, you can't do a connection. So that's basically what the port does in a simplified manner. So now let's have our, so we have our name. Now we need to specify our network. So not to make a mistake, Docker network specify. Okay, the network, Docker network create, and to use it, Docker run network is equal to this here. So I think we created a network, right? What was the name? Webinar network. So it's equal to webinar network. Docker run requires one argument. Oh, I need to also specify Postgres. Okay, so it's running now. We can also run this in detached mode. Sorry, so there's something you can also do, which is running this in detached mode. So, so when you run it in detached mode, it will run in the background. So that's basically what will happen. So now you can just do docker run -d. You are saying it that, okay, run this, but run it in a detached mode. So you don't want to see the output of how this thing is being run. Docker run. Oh, let me just remove this and let me remove the D if it's giving it an issue. Or the D should be after this, so let's see. That's the. Oh, you have to remove the name of this. Okay, so instead of removing this, let me just give it another name. Let me just call it new. So, and then put a -d, and then let's run this in detached mode. So by default, this runs in default mode. So this is not working. So let me just remove the detached mode and let's let it run without being detached. New. So now let's run this. Okay, so now let's open another bash shell. So ls cd pipeline without docker source exports bar.sh cd pipeline with docker. Okay, so now we want to run our image, which is our, let's look at docker image ls. So if you want to list the images on your system, you can do docker image ls. So the name is etl pipe doc. So now let's run this. So docker run. So what I'll just do is copy this again so that I don't waste time. So copy. So we'll paste this. So now one thing will change, and that is our Postgres user is still Postgres user, our password is Postgres password, our Postgres host is, now our Postgres host will not be localhost. Remember here was localhost. What we are going to use for this Postgres host is the name of our Docker image, or Docker container, which is the Postgres Docker container. And what was the name that we gave for this? It is what? It is Postgres DB new. Let me just copy this, copy, and then paste this here. So the host will be this. It is this Postgres. So what happens is the system knows how to. So this name of the container stands for the name of the Postgres server, and with this, our code can connect to it. So our Postgres DW is DW, but here we need to also specify our network. Network is equal to, what was the name of the network? Docker webinar, right? So network webinar. Let me go back to ensure that the name was what? Run webinar network. Okay. Webinar network. Okay. The name of the image is, the name of our image was what? Was ETL pipe doc. ETL pipe doc. So let's run this. Address already in use. Okay. Let me forward this port as 545. Sometimes, why am I forwarding this port? You forward the port if you want to forward your host port to your container port. So imagine if you are running maybe a web server, maybe a Flask web server, and you deploy it inside your Docker container, and you want to like maybe run a call or maybe run a widget on it. So if you need to map your ports on your host system to the container. You don't need it here, but it's just like for you to get introduced to how to map ports. Okay, we need to give another name. This is really, so let's just call this new, and now let's run this and see the magic. 5432 already in use. Oh, and I made another mistake again. I should have changed the port here. Sometimes there are mistakes, and the best is to learn from it. New, let me just call this new. And that is the beauty of coding, being in live coding, because things might not work as you expect. What is happening again? It's already in use by container this. Docker remove, but this should not be. Copy, let me remove this. Okay, so let's run this again. What is happening to this? Let me even remove this part, this binding. Okay, so the good thing is you have to troubleshoot, and then you get it. But the good thing is when you know what you're troubleshooting, but if you don't know what you're troubleshooting, there's an issue. So here, if you look at this, what's happening here? It says about to load into the data warehouse, and it is done loading into the data warehouse. And where is this coming from? It is coming from this run ETL pipeline. So let's do something. Let's change something here and review this and see what will happen. Let's say downloading into the data warehouse from the webinar for you to see how Docker works. So now let's view this again. This is inside. Let me go into pipeline with Docker, and let me change something here. Let me change something here to downloading into the data warehouse in the webinar. So let's do a Docker build. What was the name? Docker build again. Docker build. You tag it. What was the name of our tag? ETL pipe doc, and specify your directory. So we are building this again. It's fast. And then let's run this. To run this, let me remove this container, and let's run this. So you see, it says downloading into the data warehouse in the webinar. So this shows that you have already containerized your ETL pipeline, and you can give it to anybody that has Docker, and just send the image to the person builds it, the person runs it with this argument, and it works. So instead of doing this manually and specifying the network, one thing that Docker does and Docker has helped us to do is what is called the Docker Compose. So Docker Compose helps you to manage your containers, and with this, you don't need to run it. You don't need to do Docker run. By default, once you just start the Docker Compose, Docker run works immediately. On Windows, Docker Compose comes with your Docker desktop and Mac, but on Linux, you have to install it separately. So now let's go to the final part of this webinar, and that is the Docker Compose. So here now, what we are going to do is we are going to work with services, and then maybe someone might be confused about this Docker network. Let me just go over it before I go to the Docker Compose. So when you specify the name of this Docker Postgres container, what will happen is, remember, instead of this Python code going into the local host, it will come here and check the name of this and see that, okay, this is the name of the application I need to connect to. And then it knows the name of this application by the container name. And once it gets the container name, it will connect to the ports, because right now it knows the port, and then it can connect to this port 5432. And that was the reason why we exposed the ports when we are running the Docker, when we are running Postgres. And that was why we did the exposing of the port with -p. By default, the port is not exposed. So now let's go back to the Docker Compose everything. So here, this looks overwhelming, but it's not. It doesn't look overwhelming. Just understand what is happening. Here, you need to specify the version. So there are different versions. You have version 2, you have version 3, you have version 1. And this is telling you that, okay, you're using version 3. And what are services? Services are your containers. So that is just it. What are services? Something that runs, something that does something. What is a service? If you go to a bar, someone serve you, or if you go to a restaurant, someone will serve you something. So that's basically what service is. So you have a Postgres DB. You need to specify your image. You can also specify the container name. You can also specify the port. So you're exposing the ports. So here you're seeing map 5434 to 5432. Something I forgot to say before we go to the Docker Compose is volume. Yes, I forgot to speak about volume. So one thing about this Postgres is that Postgres by default doesn't store your data because it's a container. Remember, when we're looking at containers, we're looking at the upper directory, the working directory. By default, the Postgres image doesn't have your data that you have inserted into this Postgres container. So when you restart the container again, the container won't have that data. So if you want to persist it, you need to use the volume. I don't know if my time still remains, but you can just use the -v and then map a directory on your system with the directory on what's it called, on your Docker container. So you can just go here. I'm going to Google it. So just do Docker volume mapping. So you can just Google this and then check this. So you're going to do your -v and mount it. So just do -v and mount. But I'll just keep that. That is something you can look into later on, because I think time is going. So let's go to Docker Compose and we'll be done with today's webinar. So now, Docker composing everything, you have your Docker container image, you have your environment. So here you can specify the environment as your Postgres user, your Postgres password, your Postgres DB. Here you can also specify it as a shell, like maybe $ or Postgres user, or to keep it simple. So here you see this is how you map the volume. So you can do -v var_lib Postgres SQL data. By default, the data lives in this Postgres in the container in this var_lib folder. Is where the the data that you inserted inside the Postgres container lives. So here we are telling Docker to create a different container, which is Postgres data, to store the volume. And then we are exposing 5432 so that this our ETL pipeline can see it. By default, Docker will create the network. And here, if you look at the Postgres host, we are specifying this service name, which is the Postgres DB. You can also specify the container name. So yeah, you see that is the reason why we're specifying this Postgres DB here, which is the environment, which tells us that this is the host, and this is the host that hosts this Postgres server. And now let's go back to our folder. So now this is the Docker Compose, your YAML file. For sake of time, I won't be writing this from scratch, but you can also this is just version, your service, and then it can be overwhelming. For me too, at first, when I started writing Docker Compose, it was quite overwhelming. But one thing you just need to know is your services. And also, this is something that maybe when next you're going to learn about Kubernetes, you're going to see how to define all these stuff with YAML file. But that is another webinar. So here, your services are just your containers. And you're doing your Postgres DB, your container name, your volume, your ETL pipeline, your build. So here you're telling it that you are building it from the current directory where this Docker Compose is. Remember when we are doing Docker build, what do? We do this star. And this container name is the ETL pipeline. And we are specifying that the name of the image is ETL pipeline. So instead of using Docker build tag, which -t, we are telling it to tag it as ETL pipeline. And then we specify our environment. And we can also say it depends on this. So why are we saying it depends on PostgreSDB? Because we want the PostgreSDB to be created first before this image is created and the Docker container is run. Why? Because if this is created first and this is run first, what will happen is this won't be able to see this name of this container. So we are saying it should depend on this. So this might be overwhelming. I wish to write it from scratch, but because of time, I don't know. I need to hurry up. So what are we going to do? We're just going to do Docker compose, and then do up. So that is it. So basically, when you just do Docker compose up, Docker will provision everything, create the volume, create the containers, and run everything. So you are doing what is Docker build and Docker run in one line, in one simple YAML file. So do Docker compose up. So you see it's creating this, and then about to load into the data warehouse, and it's done loading into the data warehouse. And this brings us to the end of our containerizing data pipelines with Docker and